In this chapter, we're going to be dealing with linear motion, which is just the motion of objects in a straight line. Now, one of the most fundamental concepts with linear motion is that of speed. And speed is just calculated as distance divided by time. Now, there is instantaneous speed and average speed. Typically, average speed is the speed over a given interval. So, for example, if you went on a 300-mile trip and it took you a total of 5 hours, then you could calculate your average speed by taking 300 miles divided by 5 hours and get 60 miles per hour. That would be your average speed. On the other hand, your instantaneous speed would be your speed at any particular instant. So if you went by a state trooper and you happen to be doing 70 miles per hour on that particular trip, he might pull you over. He doesn't really care what your average speed was. He just sees that your instantaneous speed was 70 miles per hour. Now the units of speed are meters per second. Notice that the meters is a unit of distance and the second is a unit of time. So just as the formula is distance divided by time, the units are meters divided by seconds. Now in physics, we make a distinction between velocity and speed. Velocity is actually calculated by the same formula, distance divided by time, but velocity is a vector quantity, and a vector quantity has direction as well as magnitude. So a particular velocity might be 60 miles per hour north, or 30 kilometers per hour southeast, whereas the magnitude part of that, the 30 kilometers per hour, that's the speed. Now, we can compute the distance traveled either by using the speed formula or the velocity formula, simply by solving this little equation up here for distance. And in order to do that, we're going to multiply both sides of the equation by time. So if we multiply the right side by time, time is going to cancel. We'll be left with distance. On the left here, we have speed or velocity times time. And so we end up with this formula down here on the bottom. Distance is equal to velocity times time, or in the case where it's speed, speed times time. All right, the next concept we're going to talk about is this notion of acceleration. And acceleration is defined as the rate of change of velocity. You can calculate the acceleration by taking the actual change in velocity, whatever the change in velocity is, divided by the time over which that change in velocity took place. The units for acceleration are meters per second. And the way that we get those units is units for change in velocity are meters per second, and of course the units for time is seconds. So if you divide that out, simplify it, you end up with meters per second squared, and you'll often see these units as units for acceleration. Now it's very important that you don't confuse velocity and acceleration. Remember that the acceleration is the rate of change of velocity. So it's very possible that an object is moving at a constant velocity, in other words, its velocity is not changing at all. At that point, its acceleration would be zero. So if an object is moving at 10 meters per second, for example, constant, that means that the acceleration is zero, because the change in velocity is zero. Now, we will often compute the acquired velocity or the change in velocity at any particular instant by using this formula, velocity is equal to acceleration times time, keeping in mind that this velocity is the change in velocity, the velocity acquired, is equal to the acceleration times time. So a good example for this might be an object that starts from rest, and let's say it's accelerating at 2 meters per second squared. So that means after 1 second, its velocity is going to be 2 meters per second because the acceleration says that it's gaining 2 meters per second every second. After 2 seconds, its velocity, its acquired velocity, is now 4 meters per second. After 3 seconds, 6 meters per second, and so on. Now, computing distance traveled is tricky with accelerated motion, and the reason is because the velocity here is changing. So, one of the formulas that you're going to see in the reading is that if you want to calculate the distance traveled while an object is accelerating, you use this formula. 1/2 times whatever the acceleration is times the time squared. So you're going to have opportunities to use that formula in your homework and in your lab, and there'll be some more detailed explanation of that in your textbook. Now, one very common example of accelerated motion is free fall. So in other words, you take an object and you drop it from whatever distance. It falls freely and it's accelerating. And it's accelerating at the rate of 9.8 meters per second squared. Now, many of the calculations that you do in your book, they're going to round this off to 10 because you can see it's pretty close to 10. So 9.8 is the more precise value, and it's often called g. All objects fall freely at the same acceleration regardless of their mass. That's a very important point to keep in mind. Now, there's a big if there, and the if is if there is no air resistance. So, if you take a ball, tennis ball, for example, and a flat piece of paper, and you drop them both, you're going to find that the tennis ball hits the ground before the flat piece of paper because air resistance plays a big role there. On the other hand, if you take that piece of paper and crumple it up, and then you drop the ball and the piece of paper, you'll find that they hit the ground at the same time. Try that, by the way, and just do a little experiment, and you'll see that the two objects, even though their mass is different, they're going to fall with the same acceleration, and therefore they will end up hitting the ground at the same time.